Hello, hi, my name is Muhammad Amirul Ifamizadi, and today we'll be going the calculus 3 individual assignment, which is our lab assignment, and we are using the Mat491 software. And let's continue to the questions. So for the assignment, we are given two sets of questions, which is section A and section B. So for section A, the question is plot the following surface, name the surface, and experiment with the limit of the variables. So I choose question A, which is z equal to x squared plus y squared, and question C, which is x squared plus y squared is equal to 4. So for these two questions, our Mat491 coding will be using with plots to show the image, and we will be using implicit plots 3D to show the shapes. And let's continue. So for question A, we just use the command implicit plot 3D, and we enter our equation, which is z equal to x squared plus y squared. And for the limit of x, it is suitable in -1 to 1. For the limit for y, -1 to 1. And for the limit of z will be 0 to 1. And we enter, we get the shape of elliptic paraboloid. So for question C, we will do the same thing, which is implicit plot 3D, and we enter our equation, which is x squared plus y squared equal to 4, where the limit for x is -2 to 2, the limit for y is -2 to 2, and the limit for z is -2 to 2. And we get these shapes, and the shapes name is cylinder. For section B, we need to plot the solid, and we were given the option to choose from 4 questions, and I choose question 1. Plot the solid that lies between cone z equal to square root x squared plus y squared, and the plane z equal to 4. And for another question, I choose question 4, which is plot the solid bounded by the hemisphere, z equal to square root 16 minus x squared minus y squared, and the parabola z equal to x squared plus y squared. So let's do question 1 first. From this slide, we can see that I declare all the variables that I need to solve for question 1, which is the variable of x, the variable of p, the fx, and many more. And we continue to our next slide. So first, from the Mat491 software, I give the command plot 3D, where our first equation, which is x squared plus y squared square root, and where the range of x is -2 to 2, and the range of y is -2 to 2, and s equal to box. So with this command, we get the shapes. So after we get the shape, we continue to find the cone. So using the command plot 3D, which is rho theta pi over 4, where the range for rho is 0 to 4 sec pi over 4, and the range of theta is negative pi to pi, and cos is equal to spherical. And we enter, we get the shape. This is like the cone shape. Alright, continue, and we continue to find the base, and we use the command plot 3D and 4 second phi theta phi, where the range for the limit for the theta is negative pi to pi. The limit for p is 0 to pi over 4, and cos equals spherical. From this command, we get the base that looks like a cylinder. After all that works, and we can plot our last shape, our final shape, and we using the command display in bracket cone name, and we get this beautiful cone shape. And we continue to do our next question. So let's do our last question, which is question 4. So first we do our first plane or shape, and we using the command plot 3D and enter our first equation, which is x square plus y square, where the limit for x is negative 4 to 4, and the limit for y is negative 4 to 4 also, and we get this shape. Before we want to find our next shapes, first we need to declare the phi of the phi integer, and I declare that from, you will see from the slide, the blue color. And because we need to use this phi int in order to find our next shapes, so our next shape we use the command plot 3D cotangent pi, cosecant pi, theta pi theta, where the limit of theta is negative pi to pi. The limit for p is equal to, this is what we declare, p per int to pi over 2, and cos equal to spherical, scaling equal to cosine. And with that, we can push the enter button, enter key, and we get this type of shapes, and continue with that. So after that, I find the hemisphere where using the command plot 3D, and we enter the plot theta p, where the limit for theta is negative pi to pi. The limit of p is 0 to p int, and cos is equal to spherical, and cos is equal to spherical. And with that, we get this shape. It's the same as our previous shape, just different orientation. Lastly, after we find all the 3 shapes that we needed, we can display our final shape, which is display paraboloid hemisphere, where scaling equal to constraint, and we get these beautiful shapes. And with that, we can conclude our assignment. Hence, thank you for watching, and see you when I see you. Bye.